partial fractions. Decompose into partial fractions. Let's say they're given x plus 7 divided by parentheses x minus 3 close parentheses open parentheses x plus 2, and they want us to decompose into a partial fractions. What does that mean? It means to make it into a sum of two or more simpler rational expression. Let's say we're given this rational expression right here. To make it into a simpler rational expression, you let a to represent this expression. So a divided by x minus 3 plus is always going to be plus. As for the x plus 2, you make it a b to represent it on the numerator. So b divided by x plus 2. So this is the rational expression, which is the same thing as the given. And to decompose into partial fraction, you make it like that. And like this right here. By using the a to represent the x minus 3, and by using b to represent the x plus 2. Once you have that, you try to make it into a linear equation by dividing the denominator. So x minus 3 plus x plus 2 is a common denominator. So you write a bracket like that to represent that you're going to divide it. So right here, x minus 3, x plus 2. As for the right side, x minus 3, x plus 2. So this two expression goes into this two expression by 1. So you're left with x plus 7, which is right here, equals to, as for the a right here, the x minus 3 cancel with the x minus 3. So the a time, the only expression left is a times x plus 2. So write the plus right here, the same thing. As for this one, x plus 2 can divide it by x plus 2 right here. This 2 cancels. So you're left with the b times x minus 3. Once you do that, you only left with a linear equation. That's the point of rationalizing the common denominator. Once you have the linear equation, you try to solve for the a and the b. To solve for the a, you make that expression into 0. One way to make the expression a into 0 is to let x equals to minus 2. So we let x equals to minus 2 and we plug it into the original linear equation. So the x becomes negative 2 right here. So negative 2 plus 7 equals to a. The x right here becomes negative 2 because we let x equals to negative 2. Why we let x to be negative 2? Because we're trying to solve for the a and the b. So the x right here is negative 2 plus the 2, which is the same thing as the original equation, plus b. The x right here becomes negative 2 because we let x equals to negative 2. So it's negative 2 minus 3, which is the same thing right here. And you solve for it. Negative 2 plus 7 equals to 5, equals to negative 2 plus 2 equals 0, right? 0 times a will be 0. As for this one, negative 2 minus 3 is negative 5b. Negative 5 times b becomes negative 5b. The plus right here stays the same. So the next step is 5 equals to negative b, negative 5b. To isolate the b, you divide it by negative 5. The 5 divided by negative 5 equals to negative 1. So the b equals to negative 1. This 2 right here cancels. So you're left with the b. Now that we find b, we have to find a. To find A, we let the B equals to 3, because once the B equals to 3, it'll be 0. So we let x equals to 3. Why do we let x equals to 3? Because in each of these expressions, you have to think of a number that will make it into a 0. So 3 minus 3 will be 0. So we let x equals to 3. So the x right here becomes 3 plus 7 equals to 3. The x right here is 3 plus 2 equals to 5. 5 times a equals to 5a. The plus stays the same as the original linear equation. And the 3 minus 3 right here becomes 0. 0 times b equals 0. So you're left with 5a equals to 10. To solve for a, you divide by 5. So the a becomes 2. Okay? So now that you have a and b, you put it back into this equation right here. This equation right here. So it'll be the original rational function equals to a, which is 2, divided by x minus 3 plus minus 1 divided by x plus 2. Minus 1, we solve it by using the steps right here. So the answer will be the original rational expression equals to 2 divided by x minus 3 minus 1 divided by x plus 2. It becomes minus because there's a minus right here. Plus times a minus becomes a negative.